So you want to be carrier tested. What's your next decision?
Should you be genotyped or whole genome sequenced?
Haven't we already gone over this, Charlotte?
I don't think so. As a reminder, our genomes are made up of 3 billion base pairs arranged in a certain order.
And for the most part, we're pretty much the same.
So the question becomes, how are we different?
And how much of that difference matters?
How should we explain this?
Let's see, would you want to be in elementary school professionally?
A teacher.
Me too. That's as good a place as any to start. So let's say that we are both kindergarten teachers of a really large classroom.
Exactly how large?
1,000 students.
Wowza, my high school only has 152 students.
In your entire grade?
No, my entire school.
Wow. Okay, I went to a great public institution where we had thousands of students running around, which made taking roll call in homeroom a complete nightmare. Am I making anachronistic references? Do you guys do roll call in homeroom anymore?
Well, it's generally referred to as attendance, and we usually only do it during tornado warnings, but in essence, yes.
For the sake of analogy and as homage to my antediluvian upbringing, let's pretend that we're both kindergarten teachers of a 1,000-person classroom, and we have to take attendance every single day.
That's impossible. Even if you spent just 5 seconds per student confirming attendance, it would take you over an hour to do roll call. You wouldn't have any time to teach.
Exactly, but to be comprehensive, we would have to ensure that every student was in his or her seat. That's what we'd have to do, right?
I see. And that's whole genome sequencing, going base by base and determining which letter is in exactly which position.
Right, and the analogy is apt in many other ways as well. So if we take our hypothetical example of 5 seconds per student, that's a time cost associated with taking attendance. Likewise, there's actually a cost associated with sequencing a megabase. Currently, it's around 6 cents. And in isolation, it seems small and reasonable. What's 5 seconds? What's a fraction of a dollar? But in aggregate, it adds up pretty quickly. 5 seconds for 1,000 students, it's close to 83 minutes. A fraction of a dollar for a megabase for 3 billion base pairs is close to $5,000.
How could a teacher reduce the runtime of such a lengthy procedure?
That's a great question, and the way we should be thinking about it. Let's see. Did you have a group of close friends that you hung out with in kindergarten?
Sure. Rachel, Sophie, Sarah, and I were inseparable.
Of course you were, and I could take advantage of that closeness. If I could map out the relationship between my students, and I could call just 1 out of 4 of you and know with confidence that if Charlotte's in her seat, there's a really high likelihood that Rachel, Sarah, and Sophie are as well, I could dramatically reduce my runtime. Now let's abstract out. If I could break into the entire 1,000-student classroom into these 4 people groupings, I would only have to call 250 names to take attendance.
Which would mean it would only take 21 minutes to do roll call instead of 83, leaving 39 minutes left to teach.
Right. The only caveat being that it's only as good as my confidence in these children traveling together and not staying home independently.
And that's genotyping, determining which letters are in particular important spots and deriving which letters travel with them based on certain relationships within the genome.
Next time, we'll talk about the risks and benefits of such an approach.